in these next questions, they didn't give us 4 lines. We have to make our own line. So we're going to use Desmos to do that as well. So you can ignore these 4 steps for a second, and let's just focus on the next graph in our notes. So now I'm on number 1. I want to graph this scatter plot. I'm going to go to the menu up here, and I'm going to say New Blank Graph. So I'm going to hit the plus button. I'm going to add a table, and I'm going to start filling in the points for the scatter plot. And this graph shows the ages and weights of 12 babies. So the ages are in the bottom, and it looks like it's counting by ones, 1, 2, 3, 4, 5 in months. And then the weight in pounds starts at 4. And notice it goes to 10, then it goes to 16, then it goes to 22. The interval is 3 because if you go from 4 to 10, that's 6. 10 to 16 is 6. 16 to 22 is 6. And because there's 2 spaces, you're going to divide that 6 by 2. So this point here is really a 7 and 10 and 13 and 16 and 19 and 22. So it counts by 3s. So if I look at my first point, this age is going to be 0 and this weight is going to be 7. So 0, 7 is my first point in this scatter plot. If I go to this next point, I'm at 1 month and it's 10 pounds. So 1, 10. My next point is 2 months and 10 pounds. If I go to the next point, I'm at 3, and this is between, remember it counts by 3, so this is 13 and 16, so I'm going to say 14. So 3 months, 14 pounds. The next point is 4 months. It's a little bit below 13, so I'll say 12. So it's 4, 12. And then when I get to the next one, this is 5 months, and it's right on 16. So 5, 16. My next one is 6, and this is above 13. I'll say 15 or 14. I'll say 14. So that's 6. 14, and again, your estimates might be different than mine depending on how you see it. And then over here we're at 7 months, and then remember it counts by 3, so this is 19. So this is 7, and we'll say 18 because it's a little bit below the 19 mark. I get here, it's 8 and 22. So 8 and 22. 9 is this point here, 9, and it's a little bit below 22. I'll say 21. Oops, 9 months, 21 pounds. The next one is at 10 months, and it looks like it's right at this mark here. It's 3 above 22, so 25. So 10, 25 is my next point. And what do I have next? 11, and we will say that that is a little bit below 25, 24. So 11 months, 24 pounds. Let's see how many points I have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I have all my points. I'm going to move my graph so I can see it a little bit better. There's my data. Okay, so let's look at the question for this scatter plot that you made. It wants you to write an equation for the line of best fit. So this question doesn't give you a bunch of lines to choose from. You have to make the line. So we're going to go down to the next entry in the menu, and we're going to type in the equation of a line in slope-intercept form, y equals mx plus b. And we don't know, m is the slope. We don't know what the slope is yet. B is the y-intercept where it crosses the y-axis. We don't know what that is yet. It's going to let us add sliders. So we're going to hit all. And we get a slider for the slope, and we get a slider for the y-intercept. So when I look at the y-intercept, it's telling me I can put this line anywhere from -10 to +10, but that may not be high enough. I need it to go higher because these y values are anywhere from 5 to 25. So if I click inside this y-intercept box, it gives me a range I can type in. So I'm going to put 0 as the beginning, 30, and I'm going to have it count by ones. And then when I click enter, it gives me my slider for my y-intercept that can go anywhere from 0 to 30. And look at the line, it's going to move anywhere. It's going to cross anywhere from 0 to 30. So I need to pick like what's the middle. And right now I'm just going to leave it like I don't know, maybe right there. Okay, kind of get some stuff above it, stuff below it, but the slope isn't quite right. So that's this. This is the slope. I don't think I need to change these values, so I'm going to leave those alone for now, but I'm going to use my slider. And this, if you notice, just makes your line slope, if you go too fast, it just swings all the way around. So we want our line slope to kind of match the way the points are rising. So as I do this, I kind of feel like, and this again, yours is going to be different. I feel like this matches the way the points rise, but now I kind of messed up my y-intercept. This line's too high. All the points are below it. So now I've got to lower my y-intercept a little to get it in the middle of everything. So I'm going to put it, I don't know, right about there. Between 7 and 8. I have 7, I've got some points above and below. 8, I think the ones above are closer, so I'm going to stick it right at 7. Let me just try my slope again, see if I can adjust that a bit. That looks a little better. So now all my points are on either side, like they kind of go through the middle of everything. I'm getting as close to all the points as I possibly can. So there's my line. So this line equation, the slope is 1.7, and I can, that's the slope, and then the y-intercept is 7. So when I go to write this equation, I can write y equals 1.7x plus 7, and that is my equation of my line of best fit. So the next thing I want to do is, before I forget, I want to get a picture of this graph. I'm going to copy it and copy the link. You can do a screenshot, however works for you. I'm going to add it into my assignment. I've got a new link to paste. I'm going to add that link. Now both my graphs are in my assignment. I don't have to worry about screenshotting, but if I screenshot, I got to make sure I know where I put them and which ones are which to make sure when I load them up, they're the right ones. So there is my graph. Part B, estimate the weight of a baby that is 12 months old. So if I look at my line, they want me to estimate the baby that's 12 months old. So if I look at my line of best fit, where's 12? Well, right here is going to be 12. And where does that fall on the line? 12 is right there. So what is that point? I get 11.9. So 11.82, 27.094. So I'm going to say 27. And that kind of makes sense because when I look at this part of the line and I bring it over to the y-axis, that looks like 27 right there. So for part B, your answer is going to be 27.
Okay, so for example number 1, I need to write in what we got for the line of best fit. It was y equals 1.7x plus 7. And then they had me estimate the weight of a baby that is 12 months old, and we came up with 27 pounds. So we are going to go to the next page, and we've got a new question. Beth started a new bank account. The graph below shows the monthly balance of the account in the first year. So we're going to go back to Desmos and draw this graph to get this equation of this line.
Okay, so now we're on number 2 on the next page. We're going to go and get a new blank graph. We are going to create a new table of values, and we're going to look at this graph here with months and a bank account balance. The months count by 1. It looks like 0, 1, 2, 3, 4. The amount starts here at 300, and it counts, looks like 50s, 350, 400, 450, 500. So let's see if we can get these values in here. For the first entry, the first point, it's 0, and it looks like 350. So 0, 350 is the first point. Then I have 1. I'm going to say 390 because it's a little bit below 400. Next point is 2, 360. The next point is 3, 400. Next point is 4, and this is right at 450. And I have a 5 and 400. Next point is 6, and it's right at, I don't know, 460 it looks like. So 6, 460. Next point is 7, still looks like 460. Next point is 8, and this is at 450, so 8. Oops, wrong place. 450. I'm going to get to my next entry, 9, and it's right below 550, so 540. I'm going to say 9, 540. My next entry is 10, 500. I get to the next one, it's 11. Looks like it's a little bit below 550, 540. I'll call it 11, 540. And the last one is 12, a little bit above 550, so say 560, 12, 560. So I entered all my values. Let me count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Notice my values are nowhere to be seen because look at these 300s. So I need to zoom way in to find these values. There they are. So that's kind of hard to read. So what I'm going to do is if you hit the wrench, it's going to let me change the y-axis value. So the x-axis goes from 0 to 12. So I'm going to change this x. I'm going to start it at 0, and I'm going to bring it to 12. And then over here, I'm going to have this start at 300, and I'm going to have it go up to 600. And let's see how it looks now. Looks a little better, right? Maybe I'll zoom in a little bit, but there you go. So there's my data. So now I need to draw my line of best fit. So I'm going to go to my next line, and I'm going to do y equals my next entry, mx plus b. That's the equation of a line in slope-intercept form. I'm going to add my sliders. And if you notice, my y-intercept is going from -10 to 10, but look at my y values. I need to do the same thing here I did before. It looks like my lowest y value, I'm going to put 300, and my highest y value, I'm going to put 700, just like they have on the graph. And then I'm going to go tell it to set by ones, and then I'm going to hit enter, and then I can change where it crosses so that it's in the middle. So I'm going to leave that alone for now because I need to change the slope. The slope, I don't think I have to really mess with the values too much, or maybe I do. That 10 doesn't look like it's high enough. I want to make that go higher. So I am going to do the same thing I did here. I'm going to leave it at, make the smallest one, but I'm going to put it up to, let's try 20. And we'll count by ones, hit enter. So let's see if that helps the steepness. Yeah, that's better, right? Now I'm going to drag this down to be more in the middle. And if you look, this line kind of falls. It follows the shape of the way the dots move up. But where is the middle? It's really like this is where you have to kind of make the call. You want to kind of have it as close to as many points as possible. So if I put it like right around here, I've got a bunch of these points that are really high up. So maybe I need to mess with the slope a little so that it's, if I do that, it'll move up a little. And now the points are, this looks a little better. So I have some points that are on either side, but they look like they're equally far away. So this looks like my best attempt of a line of best fit. If you notice, my slope is 18. My b value is 347. If I go type that in here, y equals 18x plus 347, it graphs that line right on my line of best fit. So that is the line for that. And then it says estimate the balance of the account after 2 years. So if I look at my data, it only goes up to 12 months, right? 2 years, if you look, this is 10 months here, this is 20 months. 2 years is 24 months. So I can't really, I'm not going to use the line at this point on the graph to figure it out. I'm actually going to use the equation. So let's do that next.
So now I'm going to write my equation in part A, and it was y equals 18x plus 347. And they want me to estimate the balance of the account after 2 years. So what I need to do is I'm going to use my equation to do that. 2 years. Now this counted by months, so 2 years, right? How many months is that? 24 months. And months is my x value. So they're saying when x is equal to 24, what is y equal to? So I basically have to say y equals 18 times 24 plus 347. So what's 18 times 24? Well, I can't do that in my head. I need a calculator to do that. So if I bring up a calculator, I do 18 times 24, and I get 432 plus 347. I'm going to add 347 on my calculator, and I get 779. So the balance would be $779 after, that's the estimate after 2 years. So let's look at number 3. A 10-inch tall candle is lit. The graph below shows its height after each hour. So again, we're going to go into Desmos, graph this, and find the equation for the line of best fit.
Okay, before I forget, I want to make sure I get a copy of this graph. So I'm going to do share your graph. You can export an image. Make sure you know where it is. You can do a screenshot. I like to copy the link, and then I go to my assignment. I say add it. I add a link. I cut and paste it in. I add it, and there it is. I'm going to go back to my calculator, and I'm going to go on to number 3, and it's about a candle. And notice these points go in the downward direction because it's a candle burning. So the candle starts out with a height, a pretty high height, but then it goes down. So we are going to graph these points on our graphing calculator. So I'm going to create a new graph. I'm going to do a table, and I'm going to start entering my x's and my y's. And notice that they count by 1. So hours is on the x-axis, it counts by 1s, and height of the candle in inches is counting by 1 as well. So my first point, my x value is going to be 0 because it's at the beginning of time for the candle burning, but it's 10 inches tall. My second point looks like an hour later. It's pretty tall. It's 9 something, like let's say 9.8. That's an estimate again. You might have a different estimate. My next point is at 2, and it's a little bit above 9. So I'm going to say at 2 hours, it's, say that's 9.2 inches tall. My next point is at 3, and it looks like it's right at 9. So in 3 hours, it's 9 inches tall. 4 is the next point, and it's right also a little bit below 9. So let's say that's 8.9. That was that point. So this point here was taken in between 4 and 5. Let's say this is at 4.5 hours, and it looks like it's, I don't know, maybe 8.3 inches tall. It's not quite 8.5. So this one was at 4.5 hours, and it looks like it's about 8.3 inches tall. Then I get here, and this one was taken between 5 and 6, maybe at, I don't know, I'm gonna say 5.6 hours, but it's right at 8 inches. So 5.6 hours, right at 8. And then my next one is right on the 7-hour mark, and it's between 7 and 8, closer to 8. So it's 8 hours. And again, it is maybe 7, we'll say 7.5, it's kind of in the middle. Next one is at 9, 7 inches tall, so we'll put that there. Then the next one is a little bit more than 10 hours, so let's say it's 10.2 hours. And then if I look over here, it's below the 7, so maybe 6.8 inches. This point here is right at 11, and it looks like it's right at 6. So that point's an easy point to ID. And then the last one, 12. It's at 12, so we'll put 12. And then over here, it's below 6. We'll say 5.8. And there is your candle data. So if I look at my points, there's all my points. Maybe I will zoom in a bit. And now I need to write an equation for the line of best fits. So if I want to create a line of best fit, I'm going to type in my y equals mx plus b. I have my sliders. And then my y-intercept can, it looks like it's going to cross anywhere from, 10 or up. So I'm going to change my y-intercept values and have it go from 0 to 20. I don't want to have to worry about how it where it crosses. I don't want to have to worry about how up or down. So there's obviously the y-intercept. It's moving the line up and down across the y-axis. Now my slope, it's going to be a negative slope, so it's going to go down. So there's a negative slope, and then I'm going to move my y-intercept up. I'm going to keep kind of toying around with the slope and then moving that. And I'm going to zoom in a tiny bit. And it's funny, this has points above it and points below it. This might be good. I'm just going to play around a little bit with the slope and maybe move this down a little bit. It's a little better. If I look at that, I have points along the bottom, but then I have points along the top. So I'm going to say that's my best attempt at a line of best fit. I'm going to go down here and type it in. Y equals negative 0.4x. My slope was negative 0.4. My y-intercept was 10.4. So there's my line of best fit. And again, I want to capture that. I'm going to make a copy of the link. I'm going to go to my assignment. I'm going to add it, paste it in, and then there is my fourth graph. So I have, for each example I've done so far, I have a graph ready to post for this assignment. So I'm going to write y equals negative 0.4x plus 10.4 in my notes. And next I have to estimate the height of the candle after 15 hours.
So I'm going to write in that equation. It was y equals negative 0.4x plus 10.4 for this equation. It wants me to estimate the height of the candle after 15 hours. So what I'm going to do is I'm going to, since hours is on the x-axis, and this was the values were hours, I'm going to say x is 15. And I'm going to type in y equals negative 0.4 times 15 plus 10.4. So I just need to type in 0.4 in my calculator. Negative 0.4 times 15, I get negative 6 plus 10.4. It is going to be 4.4 inches tall after 15 hours. Okay, so let's look at the next question in this set of notes. So the table to the left shows Nick's weight each week into his diet, and we're going to make a scatter plot of this data. So you're going to go into Desmos and type in these XY values. You're going to fill in your table with these XY values. It's going to create a scatter plot. You're going to use your sliders to write your equation of the line. Take a screenshot of it and post it into the assignment. And then when you're done, you're going to use that equation like we did in the other cases to estimate his weight after 24 weeks. And notice, weeks is this is your X, this is your Y. So weeks, this is going to be your X values. So when you do this, 24 weeks, X equals 24.